Good afternoon, everybody. We'd like to welcome you to our offices here in Madrid. We are 20. I don't know if what do we do here. We are a mobile company and virtual MVNO, or it's called, and now MVNE. We do like 2.0 telephony, 2.0 cell phones, 2.0 applications for the next generation smartphones, stuff like that. So we do have a lot of interesting jobs. So if you're interested, please do have our emails in those leaflets around. And please welcome, have fun with Jeremy Mikola.
Okay, so hello everybody. We are holding this meetup in English because we have lots of international attendees today. Our speaker, Jeremy Mikola from the United States, just don't worry. We are improvising. I think Frank de Jong from PHP Amsterdam. I think Pablo Godel is around here. They're from Miami. So they are coming for the Symphony International Conference, and he was so kind to give us his talk on React. So without further delay, Jeremy, don't hide, don't be shy. Okay, great.
Hello. Good. Somebody asked for this. Okay. Yeah. You got it. Okay. Okay. Ariel? Eduardo, sorry. Thank you for the introduction. Yes, my name is Jeremy. I am from New York. I work for MongoDB. This presentation, nothing to do with MongoDB. I'm going to talk about how many people are familiar with React PHP or have heard of it? Okay. So this was a science experiment from Igor. Very interesting project. And I just want to give an introduction to it. And then also just asynchronous programming in general. So this is me on Twitter. It's my company. And I'll start with Hello World. Just an introduction for async programming. And if we start with thank you. The basic async programming using Node.js. If we were making a web server, which is the basic example here, we kind of start like this. We import HTTP, we create a server, and we specify events. And so when HTTP request comes in, we'll trigger these callbacks, and we have a request object, a response object, just like PHP frameworks. And we can build them together and fill in with content and headers and things. The important thing is different from a procedural language when we're working with async. This is going to be running in a loop indefinitely until there's nothing left to do. So after we create our routes, we'll listen on a port and a host, and then the server starts. And so this goes, and every time a request comes in, we do this. So this is Node.js, which is very much asynchronous, unlike PHP. So everything in Node.js is asynchronous. But before we get to PHP, we'll take a look at Python, how they would do this. So Python is more like PHP. It is not asynchronous naturally, but there's frameworks for it. So in this case, we're a few more libraries to import. In this case, to Twisted, there's a few different options for Python. But it's very similar. We set up the controller, and the controller just renders hello world. And we listen. We make sure we listen on a TCP port, and then we start and we run the loop. And so this will just run forever again. As requests come in, we put out hello world, and it comes back to us. So then take a look at PHP. So this is probably the worst of the three. And so in PHP's case, we have these stream functions. And how many people have used these before? There's a raw sockets, and then there's the stream stuff, which is a better layer. So with stream sockets, we can create a stream, which basically it will accept connections. So this gives us back a stream object. And then we can use socket accept and say when a connection comes in, I'm listening on the server. And when I accept it, I get another stream, which is now the individual connection. So two different streams here. And then I will use fwrite and then just fill in the HTTP, the header, and the response, and send it back. But this is very different than Python and then Node.js. We'll see why. Basically, it comes down to using blocking I/O for the input-output. So when we do a socket accept, we block and we wait basically indefinitely until a request comes in. And this is very much different from what's happening in Python and Node.js, because here we're only servicing one request at a time. So we're basically waiting for a request to come in, and then we will accept it and write back to it, and then move on to the next one, which is different from the other async frameworks in Python Node.js. And so the reason why blocking I/O is a problem is basically if we have just say the amount of work to be done. So as I/O comes in, and then we have the CPU is actually doing the string, building the string together, but I/O is doing all the network communication. And so in any web application, we have I/O and then we do CPU. And usually this is not to scale. So the I/O is much larger than the CPU. So usually, especially in a PHP app, if we look at our CPU, maybe that's rendering templates, putting stuff together with arrays, doing JSON encode. So the CPU is going to be much smaller, but the I/O is what takes longer. But if we use blocking I/O, we can only do one thing at a time. And so for all the I/O, we're going to wait a long amount of time, do a little bit of CPU, and then wait for the I/O again and come back to it. And this is a problem if, how many people have seen a chart like this before? So this is just a chart of everything from the processor and accessing memory and the cache all the way down to doing network communication across countries. And so if we look at half of a nanosecond would be inside the CPU if we're accessing the values on the registers. The things are incredibly fast to access. When we get into memory, so accessing RAM, 100 nanoseconds. And then once we get into network, or we get into disk, so SSD or spinning disk, this can be into 20 milliseconds. And then when we're doing network communication across continents, across countries, it could be 150 milliseconds for the ping time back and forth. And so this is all the time in our web application. We're probably doing these round trips, and then maybe within the data center, if you're in using EC2, and then talking to maybe your database server back and forth. So all of the I/O is on this scale, and whenever we're doing in CPU, it's usually on this scale. So the fact we do not want to wait this long and hold up the CPU work. And so the things that we care about that we'd like to optimize are the network communication and the disk, which is basically the I/O. So any whether it's disk or network traffic. And this comes back to an author, Don Kegel. This was from 10 years ago, but he called it the C10K problem. And he said this was probably 2001, 2002. He said, I can go to the store, I can buy a 1 gigahertz computer with a gigabyte of RAM, 1 gigabit, put it in a data center with 1 gigabit network connection, and then service so many clients, because everyone's internet was only 50 kilobit per second at the time. So he said, with this modest hardware, I can service so many users. But unfortunately, the way that we write our software was not suitable to actually service these, because it was only handling one request at a time. So he said, this is really hardware. We have enough hardware to do things, but we are writing software in the wrong way to handle lots of concurrent I/O. And so this led into creating more asynchronous, finding alternative ways to service all these requests. So different ways that we can solve this and do I/O concurrently and make better use, because the goal is to not wait on I/O and make 100% of the time, if possible, to constantly use the CPU. And spend as little amount of time possible waiting for I/O to happen. And so different ways that we solve this in programming. Hopefully not in PHP, but we have threading, especially in other languages like Java and C++. And so in threading, inside the one process, we can register multiple functions, multiple threads to run at the same time. And each one of them can act like it's waiting. So if this was each request, it could wait on I/O, the next one can wait, and the operating system and the language runtime will allow them to run at the same time. So this is good. It gives us the ability to do things in parallel, but the programming for it is quite a bit more complicated. and there's the overhead of having multiple threads, and then whenever the CPU actually has to switch between, so ultimately the CPU can run maybe 4 or 8 different, so many instructions at a time, and we could have web servers that have hundreds of threads. So in the CPU, there has to be switching between the threads, and so that can be expensive. And also writing the software for the threads and having to share data structures between them because they can all modify the same memory can be a lot to keep track of. But this is one approach where we can do I/O multiple times, and then we don't care about if it's blocking or not because my friend is running at the same time as well as the other request as well. But the alternative here is for non-blocking I/O, and this is what Node.js does. Node.js is single-threaded, but it does this. Python with Twisted will do this, and we'll see PHP. We're going to do this today in PHP. So with non-blocking I/O, we can use the language, and similar to we have a socket server, and we have these streams that we want to read from, and we can ask the operating system to watch. I'll give the operating system all my streams and say, wait so long, and tell me which ones are ready for some I/O to be done. So I'll give you all these streams, and then return back to me when I can read from at least one of them, or I can write to at least one of them. And then this way, I don't start my request handler, I don't start my controller until the I/O is available for me. So in this case, when the CPU, when the handler runs, in this case, that means the I/O is ready and there's not going to be any blocking here. But since this is single-threaded, that means I could still only run one CPU block at a time. So while here, there's certainly more parallel, I could run them concurrently. Whereas here, though, I'm just optimizing and I'm saying, as soon as one is done, I'll immediately run the next one. Because I was waiting for I can wait for all the I/O at the same time. And so this is the different approach. The programs, since they're single-threaded, are easier to probably diagnose, easier to debug, and then it's also probably more well-suited for a smaller, more modest hardware, certainly. So with Node.js, you have Node.js that runs on little micro robots, and you can make little robotics things with them. Whereas so it's more well suited to running better on low hardware and making better use of the CPU. So inside PHP, we have different ways that we can do both threading and the async and the non-blocking I/O. And so for threading, there's a pthreads extension if anyone has used that. It's basically the C POSIX threads for C, just ported to PHP. So if you want to do real threading, we can use that. I'm not going to talk about it. But then there's also, instead of threading, if we want things to run, we want multiple PHP scripts to run at the same time, we can use fork or open a new process. And so this is similar to how Apache pre-fork works. So the Apache web server, one of the styles that it can run in is the request comes in and it forks off a process to go service that request. So PHP has numerous tools for that. We can fork or just open a process and launch a new process to run at the same time. That certainly has overhead as well. And similar to, the complexity is similar to threading, except the processes have their own memory. But what we're going to look at today is the socket select. And so socket select and then stream select is the better, more abstract version from it. So this is using the raw file descriptors. This is using the stream resources. So we're going to use stream select. This allows us to, the select function, we can basically give the operating system multiple sockets to watch and have it and ask which ones can I read from, which ones can I write to without having to wait. So which ones are ready for I/O. And then lastly, if you've used curl, they also have their own method of this. So with curl, you can do HTTP requests concurrently at the same time. The difference here, it's not useful for us because this is just for doing the curl request. So we want something generic enough that we can do any kind of socket communication. And so see, that's what we're going to use in React. So if we were just using HTTP and you want to send multiple HTTP requests at a time, you can use curl. So this comes back to, I mentioned, we keep seeing the select function. So if we look in the man pages and we look into the C function, select is a core operating system C function. So it's in the group 2, which is for all the operating system, the system calls functions. And so select, and there's alternatives. There's some other ones that, other than select, sometimes they're called poll. or kpoll. So there's different things, different functions, but they all do the same thing. We can give it our file descriptors and the number of them and the ones to look at for reading, writing, and for errors. And we'll give it a timeout. And select will say, so I'll wait 1 second, or I'll wait, or just wait no seconds, just poll immediately and return back to me. And select will have the operating system look at the sockets and then tell us which ones are ready for reading, writing, or which ones have errors. So if there's disconnect. And so in PHP, the socket select and stream select both use either the poll or the select C function underneath. And so if in any other language that you're using, if we look at like a Node.js, the libraries that it uses, ultimately it comes down to using poll or select to do the kind of monitoring of the sockets. And so let's see what this looks like in PHP before using React, just if we were using the select function. So readable, I'll copy so I have these arrays of the readable streams, writable streams, and PHP will modify these by reference. So I'm going to make a copy of them so I don't disturb this. So I'll give my readable and writable. So those are the ones that I want to watch. Except is going to be filled in by PHP. So I don't pass in anything there. I leave that null. And I call stream select, and then here I say 1, so it means wait 1 second, and then come back to me. And then when this returns, readable is now, so I gave it all the sockets or the streams that I cared about checking for if they're ready to be read. When this returns, it will be limited down to the ones that are actually that I can read from. So after I call select, I'll basically iterate over the readable ones, iterate over the writable ones, and then I'm done. And then I can loop back. My program can do something else, and then do another while loop and come back inside the select. So this is the every iteration of when we're checking for to read or write. It comes down to basically the same idea here. So any questions so far? But this anytime, just raise a hand and we'll do questions. And so we call this, since this is the, every time we're going to come through, I mentioned, we're going to do this, and then the program goes and does other things, comes back, and then we come back again and run this. So this is going to be the loop that happens every time in the loop. So the event loop in Node.js, in Python with Twisted, in React PHP, the event loop is basically every time we cycle back. So every time the loop iterates, every iteration, we'll check all the sockets and we'll call our handlers and call any callbacks and things like that. And then when we're done, we loop back and we repeat. So that's called the event loop. And additionally, in addition to doing reading and writing, we might have timers. So we might have just a callback or a closure that we'd like to run every 1 second. I'd like to run this function, whether or not it has I/O. So those are also things that we'll do in the event loop. Each loop iteration is a tick, so we'll just call that that terminology. And then every time there's a tick, we'll do select or poll. We'll look at the I/O, and then we'll also invoke any of the other callbacks. Has anyone done game programming before with OpenGL or maybe mobile programming for games? Okay, so but in game programming, it's similar. So if you have a game, say like Battlefield or Quake or Doom or something, so you're playing the game, and when you start the game, it basically enters a loop, and every time of the loop, it'll draw the graphics on the screen, and it watches the keyboard or the mouse or things or the gamepad for input. And so it's very similar to what happens here, except now our input is sockets. In the video game, the input is the memory address for the keyboard and the gamepad. And then the timers is similar to if we're drawing graphics on the screen. So that's something that, whether there's input or not from the user, we still need to draw the graphics on the screen. So it's very similar to doing game programming, where there's this loop, and then when the user finally quits or they unplug everything, the game can stop because there's no more input. So very similar to the event loop here. If there's nothing, ultimately, if there's no sockets and there's no timers or any closures to run, then the program can finish. But usually, we're going to listen forever for incoming connections. And the other benefit here is that the timeout can be calculated. So every time we do a select, when we give it the timeout, we can, in the example before, I said 1, which means wait 1 second and then return. Ultimately, I would like to wait as long as possible until there's some I/O to be done, or if I know, so if I need to, 1 second, I would not wait for 1 second if every 10 milliseconds, I need to run a function. So then I can only wait at most 10 milliseconds. But I could wait, if I don't have any timers to run and it's only the I/O, I can wait forever until there's, because it will return when there's I/O to be done. So the polling timeout, we can calculate that if we know we need to run a function, we will use a shorter timeout. But if we're just waiting for network traffic, then we can wait forever and then have the select function return whenever there's I/O. So this is useful to be more optimal so that we don't have to, when select is waiting, we're lighter on the CPU. So it's like having it's like doing a sleep versus doing a for or while true versus a sleep. So ideally, we'd like to do a sleep and not waste the CPU spinning back and forth. And I mentioned, just like the game programming, when there's no input and there's no functions to run, the loop is over, and then the program will probably die. And so this brings us to React PHP. So this is event-driven, non-blocking I/O using PHP, because why not? And so let's go back to the first example. We had the hello world with the, you access the web server and it comes back hello world. So this is going to look more like the Node.js and the Python example now. So we're not using the stream socket except in PHP anymore. So in this case, we'll use React and we'll create the event loop. And so this is we're going to use the factory. And this is because there's multiple, React has different options for us. So we have, excuse me. So the React event loop has one that's in pure PHP, which is good because it could work with HHVM and Hack. But additionally, if there's a PHP extension installed for doing event loops with C, we can use those as well. So we'll use the factory, and then React will pick the best one available to us. And then after that, we'll create a socket server, which is just for TCP sockets. So there's no protocol. And then on top of that, we'll construct HTTP server. So this is like the layers of where HTTP server needs a socket server. Now HTTP server will speak the HTTP protocol. So now we have access to request and response objects. And similar to the Node.js example, it'll be event-based. So we'll say HTTP server. So on the request event, which means an incoming HTTP request, we'll run this anonymous function. It'll take request object and a response object, and then we can read and fill and write those together. And then lastly, we will listen on the port, and then we'll run the loop. And now loop run is going to just, at that point, the program runs, and it starts running forever, basically, in this case, until we kill it, which is just like the Node.js example. And this is, the name React comes from the design pattern that we use. So the different components inside React PHP, which I want to walk through. So the first one is, I'll start with dispatching. So we're dealing with asynchronous events. We need some way to, like in this case, to say on request. So there needs to be some event dispatching framework. So we have an event dispatcher. The request handlers are what we will write. So that is going to be the anonymous functions. So on the event, we have our request handler that will run. So similar to a controller in Symfony or Zen framework. Demultiplexer, this name basically means this is the thing that does the select or the poll. So this is the abstraction that we'll call stream select or socket select. So this will watch the different sockets and then trigger the events, which will then execute the handlers. And lastly, we have the resources, and the resources are the sockets or the streams. So in this case, we have one resource is the socket server. And then another resource, which we do not see, is every time HTTP request comes in, we get a connection, similar to the earlier example. So that connection is also a resource. So those are the streams. These are basically the streams that we, so demultiplexer will watch the streams, and then trigger the events, and then the events will execute a request handler. Any questions? Okay. So take a look at how things are structured in the library. So there's various components, just like any other framework. So there's the event loop, which we saw. That's the factory will create an event loop. Underneath this, though, we have the event dispatcher, which is a separate library. And in this case, we could have used Symfony, or Doctrine has event dispatching. Igor Wilder, who made React, decided to make his own. So this has a similar API to what Node.js has. So that's why we did not use existing event dispatcher. We made our own for that. So on top of event loops, we have the streams, and this is so PHP streams are resources, which are not pleasant to work with because they're not objects, and they're just resources. So streams will have a object-oriented layer on top of streams, so we don't have to pass around PHP resources. And that's good because we have interfaces and we can use type hinting and things like that. On top of this, we'll have the servers, and so the basic server is a socket server, and this is just for TCP sockets. So in Node.js, you have the option you could do TCP or UDP. React currently is only TCP. But then on top of the socket, now we have the protocols. And so we have HTTP, which is a server, HTTP as a client, for DNS for resolving domains. And maybe the question here is why can't we use PHP for DNS? And so one of the reasons this was a learning experience for Igor, but when originally there was just HTTP and HTTP client, and in React he was connecting to a domain and to a URL and resolving the URL. So say twitter.com, api.twitter.com. So resolving that would use PHP, and PHP's DNS was not asynchronous. And so that would be, if every time there was a resolution, that would block the entire event loop, because PHP is single-threaded, so anytime we're doing anything that blocks, it's disrupting everything. Everything has to wait for it. And so there's no solution to this in PHP. The DNS just happens naturally inside PHP internals. So instead, he wrote a DNS protocol, and it's basically just the same thing that PHP DNS does, except every time it does I/O, it does it through the event loop. So this is important. This is the first kind of realizing that if I'm writing asynchronous application, every time I do I/O, I want to use the event loop, because nothing stops you from doing, say, file get contents some URL, or doing curl in the middle of your anonymous function, and you can do that, and it will block everything. But to do things properly, you want to always, anytime you do I/O, always do it through the event loop and use the streams and let React manage and watch things. So on top of this, we have the other APIs, IRC server. WebSockets is the most popular, so there's a separate project for that. Not so many database APIs, but there is for Redis, 0MQ for doing message queues between other servers. So generally, in the community, someone has made a MySQL driver, which is okay. I made a MongoDB driver, which was less okay. But it's a lot of work to do. It's definitely harder than writing the actual PHP driver. But doing things like Redis, I think Redis speaks HTTP, so it was not too difficult to implement this. And then if you were using the helicopters, there's something for that as well, and some other things on top. So the thing that I contributed last year was, so we had originally was just the only server thing was for sockets, and this was communicating just for incoming TCP connections or outgoing. So what we don't have yet is a abstraction for file system access. So we don't have async reading and writing files on disk. I think someone in the community is making that, but not. It's still in progress. The one thing that I needed was I wanted to fork a process, and the standard in, standard out, and standard error, I wanted to connect to React so I can interact with them asynchronously. Excuse me. And this is useful because if my application has blocking code and I want to use it in React, rather than have to write the entire thing into React, I can leave this ugly blocking PHP script, and I can use a child process and say fork and go run that in a separate process. And my main React application can watch the standard in, standard out, and still talk to it asynchronously. But now I can still do blocking things inside the separate PHP script. So this is kind of a way to cheat, and it's good if you need to do database queries, say using PDO, and that does not work in React yet. You can use child process, fork another PHP script, do the database queries, and then read them back asynchronously. So this was a very quick win so we don't have to refactor everything into React. So the event loop that we start with, so we have these readable, writable streams. So when we have a socket server that's a readable stream, we basically read the socket server for incoming connections. Once we have connections and we have accepted connection, now that's readable and writable. So I could talk to the other side. And then we have the timer functions I mentioned. So you might have a function that maybe logs memory usage, or maybe runs a background job every X seconds, or every so many ticks of the loop. So those might be run. These are just closures as well. And the multiple implementations, I said we use the factory because there might be, there's different PHP extensions we can use for this. So the pure PHP, which works in HHVM, stream select loop. So this uses the stream select function in PHP, doesn't need anything in C. But then there's also libevent loop, uses the PHP libevent extension in PECL. And then there's libev as well. And then there's one more, which is libuv, which is not yet ready for PHP. But I believe libuv is what Node.js uses. So that's important for PHP because right now, if you have Windows, you can't use any of this except this one. So these are only on Linux. But libuv works on Windows as well. So hopefully when that is supported, we'll have another factory interface for it, and then you can use it in React as well. And so the event loop, this is going to be like the last example, except I'm not going to use the socket server. I'm not going to use the HTTP server. I just want to use the event loop. So again, we use the event loop, and the server, I'm going to use the raw PHP function just to show just what the event loop does by itself. So socket accept server, similar to the first example. This is the same thing that the server component in React does. It uses stream socket server. Set blocking 0 is important. That means anytime I'm interacting with the socket, I don't want to wait at all. So if say I'm reading from the socket and then I reach the end, I want it to return. I want it to stop immediately and then come back to the event loop. So usually with any async programming, you want no blocking. Make sure you would set that to 0. And this is what React will do internally for us as well. And so once we have a socket server, I said that's listening for connections. So that's something that we're reading from. So we're going to read for incoming connections. So in the loop, I register the stream. And so I say, I want the loop to start watching this. And the function, the callback for this is going to be inside the server. So I'm listening on the server, and then the function will take the server in the loop. Once there's some activity to read, which means that I can now call stream socket accept. So inside my closure, I will accept the connection. I will build my data. So this is going to be the HTTP header and the response. And now, before I'm not going to use fwrite just yet. I'm going to add this as a writable stream. Because if I just wrote immediately, I might be blocking. So I might try to write the data, and then it realizes that the network buffer is full, and then I block, which is bad. So instead, I will add it as a writable stream. And so anytime I'm able to write to this without blocking, this function will get called right here. And so the function will take the connection, and I'm going to take the data, the response basically, and the loop as well. And the one thing I have to do here, and this is what React will make easier for us, but every time I do fwrite, I will write as much as I can, but I have to check if I wrote everything. So usually this is 42 bytes. So usually if I write this, it'll write immediately. That's fine. But let's say the person was downloading a large file, so that it was like 500K response. So when you're fwrite, you will probably have to fwrite multiple times to exhaust the whole 500 kilobytes. So what we do is keep track. Fwrite will return how many bytes have actually been written. So let's say this was much longer. This might return 100. So I'm going to snip off the first 100 and then keep whatever is remaining. And when I reach the end, then I know I've written everything, and then I can return. But when I'm finally done, if I've written the entire length, then I can remove the stream. But so this is basically, this will probably be called once, but it may be called multiple times. Does that make sense? Okay. And then finally, I make sure I remove my stream when I'm done to clean up, because they close the connection. And then lastly, we'll run the loop and start listening for incoming connections. So this is what the loop does by itself, which is still would be annoying to have to write all this. So we're going to use the other components to make this more friendly. So this brings us to stream. So I mentioned PHP has these stream resources instead of using raw file descriptors. So PHP adds a wrapper for this with classes. So these are the things we can, we saw in the last example, I can register a stream resource with the loop, but I could also register a stream itself. So I can use either. Streams, we can read or write to them. And the important thing is I do not want to write this every time. I don't want to think about this. I just want it to work. So instead, we'll have the streams can do the buffering for us, which is just convenient. You don't have to think about the snipping the data and making sure it writes it iteratively. And so I just want to go right through the interfaces. So a readable stream, this returns true. And the readable stream, we can pause it, resume it. This would be to stop any of the I/O from in the event loop. We can use pipe to connect it, to join it to a writable stream. And that would allow React to just move the data between them so that we don't have to write the code to do that. And then if we if we terminate the connection, we can close it. The main events that we care about are probably data, which means anytime the data event is triggered, that means I can read from the stream. These, like an error is if like a connection died. If I decide to close, then I might have other things listening on close. So maybe there's some separate callback that just wants to watch when things get closed and do a logging. So that might listen on close. But basically, data is there's data to read, and then end is you've reached the end of the data to read. So these are the two most important ones. On the opposite side is writable returns true. We can write data. We can end, which is basically write this and then close it immediately. So that's like write the last output, and we can just terminate it as well. The main events are drain, which means that I did a write and I wasn't able to write all of it, so it blocked, or instead of blocking, it returned to me, but I did not write everything that I wanted to. So drain would say that now you can write again and send me the rest of the data. So this is used internally for the buffering, but usually you will not have to use any of these. The other notable one is probably close, and then pipe would be if a readable stream pipes to you, you get a pipe event. So readable and writable, Mario is the data going between. So this is good. But we want a composite stream, so a connection that we accept, we can read and write from. So this is a composite stream. So that's great. And then we have one object to work with that we can do both sides. It has both interfaces. Through stream, we can filter the data. So say you wanted to do rot 13, I don't know why, on all the data that goes through, and you want to just play with the strings and then have something else read it later. So just do like a filter. So that would be a through stream, and there's a basically an interface for this, and then we can basically wrap another stream with a through stream and add a filter function. And then buffered sync is nice. So with streams and any async programming in general, when I'm dealing with when I'm like reading connections and things like this, I would prefer so that I know the data when I read it is gonna maybe come back in different chunks. But I would like it to be all returned to me. I don't want to think about the async and then having to do multiple loop iterations. I would just I would like to read the data and get a single result. And so in many, React did not invent this. This is something we have in Node.js and in JavaScript as well. The concept of a promise. So we want to have a readable stream or a writable stream, just any stream that has output, and then convert that down to a promise object. And now in my application, I can just deal with this. So we'll have a segue. This is discuss a little bit what promises are quickly. So it would be nice if asynchronous function, instead of having callbacks invoked every time, I'd like it to return immediately and just have a value that I can collect. And so the benefit here is with the promise design pattern, we have the two things here. One is deferred, which represents some unit of work that will be complete later. So this represents the asynchronous task, basically. And in a deferred, we will basically return this back from our in the library, we'll return back these objects. And inside, if we think about, so the one example will be the DNS resolution. So inside the DNS resolution, we will immediately return a promise to the calling code to our application. But inside in the asynchronous, inside like the DNS component, when we finally get the response from the DNS server and we've resolved the domain name down to an IP address, we will then call resolve, or we'll call, if there was an error, we'll call reject. And so we will call promise to return something right now, and then later we'll call resolve reject or progress to update status to fill in the value at some later point. But the important thing is that the promise was already sent back. So the calling code can just call us and immediately get something back and not think about it being so asynchronous. So we don't have to have having callbacks that go like this and then all the way in and then come all the way back out. So we can just call our function and immediately get back promise. And the promise itself is a placeholder that our application will take. And so it has basically, I think, two functions, or the one that we use most often. Then, so when we get a promise, so think of like a DNS result. I'd like to resolve a domain and then do a HTTP request against it. So I would call the DNS service. I'd get back a promise, and then I would immediately call the then function and give it more code to run when the promise is finally fulfilled. And so this way, I can structure my code and write it like a normal program vertically instead of having all these nested callbacks. And with the then function, the first argument is on success, I will run this. So in this case, after DNS completes, then do HTTP client connect, and that will be the success case. Rejected would be an error or throw or abort the program. And then progress is not often used, but that would be for like logging % complete or something like that. And the important thing is every time I call then, I get a new promise back, and so I can keep calling then. And if everything goes good, then we just keep running unfulfilled. We run the first fulfilled callback, then the next one, then the next one, then the next one. If anything is an error, it will be rejected, and then we'll start calling rejected callbacks. So example of what this looks like, because it's kind of complicated. So again, we create the event loop, we create a factory, and I'll create the DNS service. And this will use Google DNS for, and I'll register it with the event loop. And so DNS, I'll resolve the first argument, and then if on success, I'll print out the host. Otherwise, I'll print out the exception message. Excuse me, and then I will run the loop, and this will return immediately. So let me just have a demo here. So I'm not making this up. So this is DNS. So meetup.com, and it gives us back the host here. And so in this case, I could connect this with more thens and then use the HTTP client service to then connect to meetup.com or connect to Twitter and access the API. And so this is that's basically promises. To read more material on this, this is a very good article. The slides have all the links, so I would recommend this for later. But go back to React now. Any questions about promises with React? So it usually is used with the services. So if you're writing a database driver, or if you're writing another like a IRC server or something like this, the library will want to provide promises. If you're just using React as the application, it's much easier, and then you can just use then. So depending which side, if you're making a shared component versus a application, you will use different sides of the promises. So back to React. So the sockets. So again, on top of the actual stream resources, we have the socket server, and so this is the connections come in and they're readable or writable, and the server and client. So there's opposite sides to it, and they're all TCP connections currently. And a server is a very small interface. Basically, we saw the function listen. So after we construct the server, we set up the events with on and then on connection or on error. We will listen on a port and host, and then we just have a function to get port, and we can shut down and kill everything. So in the other example, we did, after we constructed this, we did listen and then we did loop run, and it will run forever. But if we called shutdown, then that would allow the PHP script to end because it would be unregistered. And so every time we get a connection, so on connection, we'll get the connection object given to our function, given to our anonymous function. The main function here is, so this extends a readable and a writable stream. So it inherits all of the existing methods. It has the same events as well. So data event, we can read. Drain event, I can write again. The only new function is remote address, which is the client IP address and port. And so we'll see this in the demo example if you have it working. Your hotspot? Yes. Okay. Great. So this is a slightly bigger program. So the Wi-Fi is not allowing us to use Telnet, but you're on hotspot. Oh, you can make a hotspot. Oh yeah, make a global hotspot. Okay. So we can try to do this. I don't think anyone is watching on YouTube, but they can access this as well. All right. Yes, does it work? So chat. Yes. So this is the same script in the previous thing. I'll run the demo first, and then I'll explain what's happening. So chat.php. So this is going to be a chat room using just TCP sockets. So there's no protocol or anything. It's just basically you're going to type something, and it's going to echo it back to everyone else that's connected. And so this is running, and then here I'm going to do telnet. Start the script first. Telnet jmikola.net all 8. Do you want to type something? Okay. So I'll leave this running. If you get it working, just keep putting. People usually paste stupid things. So I'll come back to that later. Okay, so what's happening here? We create the event loop, and we create the socket server. So we're just going to use TCP. We're not going to use any of the things above that. And then, does anyone else like SPL library in PHP? It's good stuff. Yes. So good opportunity to use. There's always hard to find a good reason to use these things. SPL object storage is just an array of objects. Great. So I'm going to use that to hold my connections. So that's my connection bag. So socket, every time a connection comes in, I'm going to use the object storage. I'm going to register my connection and keep it there. And now on that connection, so now I've accepted it. I have this connection. So again, with React, we didn't have to do stream it except server. It basically does that for us. So we get a connection object here. Connection on data comes in. So I will again use all the connected clients and the connection, and then go through everybody, and I'll skip myself. So if the connection is me, I'll continue. Otherwise, my data that came in, I'm going to write to everyone else and give my IP address and then the data that I typed. So when Maximo connected, he said hi. So it gave his IP address : hi, and then writes it back to me because I was also connected. Lastly, at the end, so if someone disconnects, I want to make sure I clean up things because otherwise I'm going to be writing to sockets that aren't connected anymore. So when someone disconnects or there's an end event, I'll detach it from the object storage, which is good cleanup. And then lastly, I'll listen on that port and then run the loop. I don't know if anyone else has typed anything. No, it's very lonely. Okay. Oh, that's you again. Okay, great. All right. Okay. And I don't know how to close Telnet, so I usually just close the computer. So that's the TCP chat. Any questions about how this works? Good. Yeah. It's usually more exciting when we have everybody spamming the same thing. But so this is if it didn't work, this is the example. So the other example here is so that's using using React for, so that was just TCP chat. There was no protocol, but we can build. So maybe if you wanted a protocol on top of the socket thing that spoke JSON or anything on top of that, you would do it in a similar manner. So that was just a basic example to show how we can juggle multiple connections. The other example, and this is the reason that I wrote the child process component. So in this case, I wanted to be able to query MongoDB and run things in the Mongo shell. And there was no way to do that asynchronously in PHP. So I could do fork and then write to the IO, but then juggling that back and forth was a pain. So instead of using React's child process, what I basically wanted to do was either to run Mongo queries. In this case, I'm going to use the shell, but this could easily be a PHP script, and then I can get the standard out to read it back in my React program. But here I'll launch the shell, which is just like the MySQL shell if you've not used it. It's a JavaScript shell. And the standard out my local standard out, I will open a stream. So inside the React process, my standard out, I will create a stream for it. And this is just so that I can write, because I want to run the Mongo shell in a forked process, and I want its output to be echoed back to my standard out. So to do that, I need my standard out to be connected to React event loop, and so I will fopen the standard out and then wrap it in a React stream and then register it. So process, when the process dies, I can get the exit code and the termination signal. I don't care, but I will just close my standard out. So as it's open, it'll be connected, and then when the Mongo shell dies, we'll close things. Because when you fork a process, and this was kind of a caveat, when I fork a process in PHP, I can't, it creates the standard in, standard out streams, but I need to wrap those. I don't have access to them until the process is actually running, which is unfortunate in React because we would like to have the streams available immediately to be able to connect to things. But in this case, I have to do a timer. So as soon as we launch the process, as soon as possible, basically, then I will work with the streams. So this is a kind of a problem with just PHP process control in general. So as soon as the loop starts, as soon as I fork the Mongo shell, I will start my loop, and I want to connect the process standard out to, I'm going to pipe it to React's, to this application standard out. So this is using pipe. So the process standard out is a readable stream for me. Inside the process, it's writable, but for me, I'm reading from it. And then my standard out stream is writable. So if that makes sense. They're named the same thing, but they're on opposite sides of the connection. And then after 1 second, so just wait a little bit for this to happen, I will, using my, the timer takes the timer function, but I'm going to write to the JavaScript shell. I'm 5 different commands here. I'm going to drop the collection, insert 3 documents, and then do a query just to show them come back. And then I will exit. And so in this case, slides async. So MongoDB PHP, see if Maximo did not type anything at all. Nope, okay. Right. You're here, yes, okay. So first I'll run Mongo. Yes, there is something in here, so we should, just to show that it will get dropped. Okay, so we have some garbage in there, that's fine. And then PHP Mongo. So it connects. This is basically the output. We're not seeing what it wrote to the shell because we're just piping the standard out. But it did db drop, so true, that's success. Inserted 1 thing, 2 thing, 3 thing. And then we did the sort where by X descending. And so we just come back with, so these documents were gone. And now we just have the 3, 2, and 1 that we inserted. And then when we exit, it says bye, and then it says shell exited. So back to the slides. So this is a basic example, which is not useful because it's sending back text. But think of it in a better example, if it was a PHP script that, or in the Mongo shell, if I wanted to, I could echo and just restrict it to JSON output. Or certainly in a PHP script, we can send back serialized PHP values on standard out and maybe put a new line at the end. So this is the benefit of basically how we would be able to talk to another process, and then we can implement the logic for reading the results. So instead of just echoing it back, we could do on data for the process standard out, and then every time there's something to read, we could take action inside the React program. Any questions for this? Okay. So in either case, with React, so I mentioned this with the DNS example. So why there's a DNS component is because the first time we had PHP do DNS resolution and it blocked, which is bad. So in any case you're doing asynchronous programming, we have to think of the cases to avoid blocking where we might not expect it. So certainly that means database queries or connecting to a database. So if you're just using MySQL functions or PDO or just the MongoDB driver by itself, those will be blocking I/O because they happen outside of React. Anytime we do disk and file I/O, So maybe even for things like logging. So if you're using monolog and you're writing to a file on disk, or using even PHP's syslog that's writing to syslog on disk, these are all cases where maybe you won't notice it because the file IO is usually fast, but every now and then it could be a problem. And especially in a web situation where you have maybe you're using NFS, and you have network drives, or you have S3 buckets that are mounted to directories, and so you think it's IO, it's file IO, it should be faster because there's no network, but we don't know if it's communicating over the network. So this will be very useful when the file system components are more useful or more mature. Also, CPU intensive tasks. I don't know if anyone remembers, there was it was a blog post from somebody that likes to complain, and it was about Node.js, and the guy was using Node.js to do Fibonacci numbers, and he was complaining that the performance was horrible, and it was not asynchronous anymore, because he was basically doing big CPU calculations. There was nothing to do with I/O, and so he was complaining Node.js sucks because I can't compute Fibonacci numbers. So great. In PHP's case, any CPU intensive task, we're probably not Fibonacci, but realistically, if you're doing JSON encode, or you're doing maybe you're working on big array data structures in PHP, even the basic, like a JSON encode on a very large PHP value, or maybe a serialized or unserialized on a large value, can take a long time to complete. Similar to when you do a var dump on, if anyone uses Doctrine for ODM or ORM, and you do a var dump or something, and it just spits all this data out because it has so much data to go through. So anything that will be using a lot of CPU, we have to be mindful of to try and break that into parts. So solution for that, so for each of these, so in the first case, for database queries, disk I/O, so to use inter-process communication. So in the case of either using something like a message queue or Redis, which would be certainly faster to communicate with. There was Stomp and dnode for IPC layers as well, even using the child process. So forking another process and then reading standard in, standard out, and doing the blocking stuff elsewhere, and then keeping your actual async application completely async. That helps. Using message queues to do, so if there's background jobs to do, maybe there's someone uploaded a file, we need to process it. I will not do that in React. I will not do the disk I/O in React. And I don't want to launch another process, but instead I'll just put a message into Zerum queue and broadcast and say that the background worker daemon should pick up this job and do it later. So that's certainly another option, just have separate, and then your worker queues, you can have as many of those as you want, and they don't have to be asynchronous. And that'll, again, keep less of the work outside of your React application and let it just focus on the I/O. And additionally, if we have large CPU tasks, what React lets us do, so we can have functions that run every 1 second, or so on every interval. We could have functions that run every loop tick, and we could have functions that run only once, but I want it to run 10 seconds from now. So we have those options, but we also have next tick, which just says, run this callback the next time the loop iterates. And so this is important if we're doing something like maybe a large for each, and we're calling some complex method on a collection of objects, right? And maybe we're processing them or we're analyzing them in some way. If I use next tick instead of, in my React, instead of one function just iterating through everything, I'll iterate through 10 or 15 of them. And then remember which ones I finished, and then the ones that are remaining, I'll say in the next tick, I will do the next 10. And the importance of next tick is I will again yield control back to the loop, and then that'll allow it to look at the I/O and then dispatch requests that may have come in. And so this ensures that I can still do my job. I'll do it in chunks of maybe a little bit at a time, and then I'll keep taking breaks to see if there's other I/O that has to be done. I'll still respond to that I/O and then handle requests and everything. So then my users don't realize that I'm doing this background task because their requests are still getting serviced very quickly. So this can be useful. It just needs some bookkeeping on your end to decide how much do I do, how much do I split up at once. So and additionally, while I was researching all this, was about a year ago. Inside the MySQLi extension, they do have this function here for poll. And this is for doing async MySQL queries, which is useful. We could do multiple MySQL queries and get back these handles. And then this poll is similar to the select function that we were looking at before. But unfortunately, it's not useful to React because it's just like the curl select. This is only useful for using multiple MySQL queries asynchronously. So the polling is only happening inside the MySQL driver, similar to the way curl is doing it. So while this is good if you're only using MySQL and you want it to be asynchronous, for React's case, it's not useful because I can't watch the MySQL sockets the same time I watch the other React sockets that I might have connections open. So while this is good, it's not entirely useful to us for React. But I wanted to make mention of it. So this is probably something in a similar direction. The community MySQL driver will be a better option for React than using this function. So yes, it looks like stream select. Great idea. So if you're interested in playing around, examples 0.4 is the current stable version, which is not 1.0. So this is not stable. Some people use it in their companies. Good, they're brave people for using that. But generally, it's more people experimenting with it and using it on small projects. I'd say the big project that uses it in production is the WebSocket library. So this is from Chris Bowden, is the other React core contributor. So he and Igor are the main maintainers of React. His library is called Ratchet, and you can look at that. This is useful. Any PHP application, if you have existing PHP. So a common question is, why would I even do asynchronous programming in PHP? If you have existing code, existing libraries and models and things that you already have existing infrastructure that you want to leverage, maybe more so in the case of WebSockets because maybe your data models can be shared. It makes a lot more sense than picking up an entirely new technology than having to manage a separate either an async Python or a Node.js deployment. So this can be, it's probably not the best option for asynchronous programming, but it's certainly viable. And this is, WebSockets is definitely very usable today. And then on a lighter note, Alvaro Videra has GIF sockets. So if you're on IE 6.0 and you want to use WebSockets, you can't, but you can use GIFs. And so this is good for sending back. So he made it, I forget which language he made it in. Pablo, if you remember, it was Scala or Clojure. So obviously it needs to exist in PHP. So we ported it to React, and that's available there if you'd like it. Thank you. I'll answer any questions. Everything that I talked about is on reactphp.org. And the GitHub is also easy to find. I think GitHub React is Facebook's. So GitHub React PHP is our project. But thank you.
¿Sirve de algo? Sí, vale. Si tenéis alguna pregunta y no os animáis a hacerla en inglés, pues os puedo hacer de traductor y si no, en inglés directamente. Any questions? Don't be shy. This is an easy topic. Nobody? Great talk, no doubt. Okay. ¿Algo más? O... No, de las licencias y eso, ¿no? ¿Álvar? ¿Sorteamos? ¿Hacemos el sorteo? Bueno, pues vamos a sortear las licencias. Pues nada, os quedáis sin licencias.
I have WorstCon stickers. Anyone WorstCon? Anyone watch it? The Hot Dog Conference? Okay, we're up here.
Bajando, ¿eh? Okay, in English. As we usually do, at the base to the right, we have the bar. So we go there to grab some beers and see you there for the networking or chatting or whatever you like. See you.